Good afternoon, and I hope you all had a lovely afternoon too. My name's Anna, and I work in the Geological Survey. And this project was undertaken with CSIRO, Ryan Noble, and Dave Cole as well. So I'm very excited to tell you about this low-impact, smart exploration tools that we're using here in South Australia. In particular, the results from a recent biogeochemical survey and ultrafine survey, which was undertaken in 2020. So I'm humbly opening the Big Data Projects session here. In the next 10 minutes, I would like to create a vision of the future where mineral exploration has a very small footprint, low impact, sustainable and cost effective, and also complementary to the big data projects that I'm opening this session for. And today we'll be focusing on doing more with less, building on past programs to create new search spaces, create baselines through regional characterisation of areas, and review regional survey results. Low impact makes for smart exploration. We've seen this with Marmota, successfully applying low impact biogeochemical and plant sampling at their Aurora Tank prospect in conjunction with the Calcrete sampling program. Their plant anomaly, they had a plant anomaly without a corresponding calcrete anomaly, and which was followed up with drilling early in 2021. And this drilling intercepted an unknown extension of the main prospect, which is really great proof that biogeochemistry is really useful in these areas of regolith cover. In March, Marmota have been following up this phase 1 sampling with 1,800 new individual sample locations, covering approximately 300 kilometres square of ground on a 400 metre spaced grid, and extending outwards from their Aurora Tank to the surrounding tenements. So at each location they took calcrete as well as a plant sample, and they're going to be looking at contrasting and doing some infill sampling from this work, and it's all part of the ADI supported exploration initiative, which is great to see. Also, in our round 2, which was discussed earlier by my ADI funding recipient Sinosteel SA, have been looking at plants and regolith characterisation to boost their exploration success in the Curnamona. So how and why? How are we doing this and why are we doing this in the Gawler? The aims of the project have been to utilise ultrafine plus technologies and data integration in mature exploration space in South Australia alongside landscape and neotectonic studies, also using SARAG and our online portal. We've been looking to help boost the baseline geochemical dataset for regional cover sampling, which can be adopted across South Australia over the next 10 to 20 years is our aim, and to create a statewide geochemical dataset. And finally, we'd like to advance exploration success through delivery of new geochemical data for the central Gawler region. And for this project, we were mindful of cultural and environmental protection zones, so we excluded those from the possible survey area. And this also forced sample selection to be within 100 metres of accessible tracks in the remote region, and then we determined about 150 soil and plant locations which were representative for cover and area. It made sense to sample the plants as well as the soil, which is why we've done both, with plants tapping into soil and groundwater, and with their unique ability to accumulate and then dispose of nutrients via leaf nodes, and plants can attenuate our understanding of soil geochemical results. Plus, it's a chance to build on past research projects through LEAN, DET CRC and Geoscience Australia vegetation surveys, plus the Far West Biogeochemistry survey undertaken by the Geological Survey and collaborators in 2014. So, some of our techniques, just a quick overview. LabWest have been used for analysis of both the plant and soil samples, and this research forms part of a larger research collaboration between government and industry via CSIRO LabWest project. On the left in the slide here, you can see we've got our plant samples lined up for drying, and then we've got our soil samples also set up for packing. In the middle is the plant samples actually getting ready to be prepped, and on the right you can see we're actually sampling, separating the leaf and twigs, just because a lot of the plants didn't have much plant growth. It's been very dry, not until we went up there and then it rained. But of course, it's so we tried to sort of separate that out and have a consistent sample medium. For the soil analysis, the Ultrafine Plus workflow at LabWest incorporated the collection of the less than 2 micron fraction from soil samples, analysis and reporting of gold plus full element suite by ICPMS, and measuring the pH and conductivity of the samples, and sample size, particle size distribution formation, and looking at the visible and near-infrared mineral proxies for the finds. And the patterns that are evident in this data really relate to the likely landscape position and climatic changes. The biogeochemical samples, as I said, was also sent to Lab West after drying in preparation at the South Australian Drill Core Reference Library. Leaf and twigs were separated. We sent them to Lab West to be milled, and up to 2 grams of sample were digested by a microwave-assisted digest using a modified aquaregia solution. So we know South Australia is a terrific place to test low impact and smart exploration, and while we have up to 80% regolith cover blanketing the state, it is also for the most part pretty shallow. Zooming in, we can start to see why exploration has concentrated on areas where depth to basement is modelled to be less than 50 metres. These are areas close to exposed rock and usually exposed gossans or geology with economic minerals that have been easily detected and mined. This image shows known prospects and deposits hugging the outcrop, and yet so much of the region is subcrop to 50 metres depth to basement in the survey area, which is shown in the green rectangle in the middle. This study has been designed to demonstrate the ease of use of plants for sampling, and we are very much past the development phase for this technique. We're not testing whether it works or not. We know it does. It's been used by companies. We really wanted to create a regional data set for the area to, hope to see more sampling, more biogeochemistry, especially happening in this area. Here is our survey area, and the surface geology can be broadly classed to 4 types in order of greatest area, from quaternary sand dunes in the southwest and northwest, quaternary custrine and sand sediments around Mesoproterozoic outcrops in the southeast, Cretaceous shale and minor Cenozoic and quaternary cover in the northeast, and Jurassic Cretaceous sandstone and Archean outcrops in the central and northern area with quaternary and Cenozoic cover. So in the past 100 million years of landscape evolution has meant rocks and soils have been stripped and the new soils developed. And this means that where transported sediments are sampled, and also soils and plants, they may not fully represent the underlying geology, but a possible combination of transported and in situ materials, which has really made the statewide regolith geology map produced by the Geological Survey and Common Crap in 2012, plus later map products, absolutely essential in this area when doing any sort of exploration. This study complements 2 previous geological surveys, the 2014 biogeochemical survey with Colin Dunn and Helen Wardren, as I said earlier, and also it's been followed with the GeoSA CSIRO project headed by Carmen Krapp and Ignacio Gonzalez Alvarez, with a new regolith map of the Greater Tarcoola area, one of the many highlights from this project shown there, and I would really recommend going and having a look. Just quickly, the interpreted basement geology, which we heard about earlier with Mark Pawley, for the survey area encompasses the Mulgathin Complex, Tunkilia Suite and Tarcoola Formation, plus also targeted units within the Harris Greenstone Belt. This is a map of the survey area, and you can see that it's not just a regular grid. The soil sampling was designed to be smart, and that's to take in as many variations in regolith, soil, geology and landforms, as well as being accessible by vehicle along roads. So everyone who's familiar with the Campana geochemical survey work especially would know that looking at just taking all these different variables and planning your survey design around that. We've really tried to do it to the next step here with the Gawler survey and really see how we can just get a really good cover of the area and not just sampling the same regolith type all the time, because you're always sampling to a grid that's always in the swale or always on the edge of a salt pan or something like that. We have used the machine learning to design a survey that takes in soil, landforms and geology to ensure samples are representative. Each of those samples each site took about 10 minutes to collect a soil and plant sample, and often we had more than one plant sample. We would also look to collect multiple samples of plants so we can compare the different species at each site when we could. And we do have about, I think we have about 40 sites where we can actually compare a couple of different types of plants, which is great. And as well as log details and photos using the FAMES program on a tablet. I don't think there's any introductions necessary. We have wonderful chenopod's across the region that we targeted, the pearl blue bush, the bladder salt bush and black blue bush. The real stars of the project have been these chenopod's. They're there for a long time and they're pretty much drought proof. Sometimes you're just sampling twigs and they're pretty easy to sample as long as you pack extra replacement nitrile gloves. I'd like to zoom in even more now and see what has worked in our recent program and detail the finer nuances of this work and how it is helping provide context, background, and hopefully some really interesting and useful data sets for the upcoming big data projects. Here's some of the Ultrafine Plus survey results, plotted up as GK plots. This is all going to be written up into a report and an article soon, but Ryan Noble's giving me permission to talk about it here today. We can see that the soil results reflect the clay-dominant soil fraction sampled, and we have these really interesting peaks for aluminium, calcium, cerium, and rubidium, which possibly reflects the analysed minerals that have been recorded, including kaolinite, montmorillonite, and muscovite. There's also some phengite, illite, and paragonite, so some really interesting things. And this is part of the products from LabWest, so it's really great to have this mineralogy from the lab to accompany your geochemistry. When we plot these soil results spatially, we can instantly see a good spread of background values across the large survey area. And gold values in this region show representative backgrounds of 0.25 to 10.3 ppb and a mean of 1.5 ppb. There are some elevated responses, such as nickel and gold, but these are background values, and even the highest gold is not a target. And it will be really interesting to see, to use this data for future programs, which may look to further define this surface geochemistry and generate targets in the Western Gawler. When we plot comparison 2K plots for gold, parts per billion between ultrafine pearl blue bush and bladder salt bush, we can see that the ultrafine soils are a lot higher, but then the pearl blue bush and bladder salt bush are pretty similar in their geochemical response. I did have black blue bush up there, but I found it really hard to scale it down enough to look nice on the screen, so it's actually like really low compared. So I think whether that's because they're a different geographical distribution, need to dig into that a little bit more, but some really interesting results to take away from this and compare to other programs that have been in the same area. And we actually also did do a lot of duplicate sites with the Far West Biogeochemistry program and some of the Geoscience Australia programs also. So we have some really great data sets to dig through. When we look at the pearl blue bush results spatially, we can see for most commonly sampled plant across the area, it's a really good spread. There's about 200 samples of pearl blue bush that we used in this, that were sampled in this program. It is interesting to note that the elevated background levels of nickel is located in the central to southern part of the survey area. And this may be related to the salt lakes, or reflects the subcropping Harris Greenstone belt, and definitely warrants a bit of further investigation. I've just lost the slide, that's okay. Cool. So really the next steps is the Gawler Phase 2 integration, and really looking at how this data set can value add the work that Stefan Thiel's going to talk about next. We're linking in with previous regular studies and new ideas for surveys and, for the Western Gawler, and we're really looking at analysing the results from regular landscape study, CSIRO and GSSA. There's some really great targets that were defined there, and really we'd like to look at how our regional data set compares to that and whether there's any follow-up required. It'd be great to see. I'd just like to thank everyone involved in the project, and for those who've had input to the project too. I think most of the people here in this room from the survey have been really helpful during getting this project going, and also all these people from CSIRO and beyond. Thank you.